Welcome to Die Casting News. Today, we're tackling a problem that starts right on the shop floor, air in the mold, but has huge implications for the modern demands of your entire supply chain. Let's get into it. So, here's a question that's probably cost you a lot of time and money. Why does a casting that looks perfect, that even passes dimensional inspection, suddenly fail the moment it hits the CNC machine? We're going to break down exactly why that happens and, more importantly, how you can prevent it. All right, here's our game plan for this explainer. We'll kick things off with the basic physics of what's happening inside the mold. Then, we'll look at how the very definition of a good casting has changed. We'll connect that to the power of an integrated workflow. And finally, we'll look at the hard data that proves it all works. Okay, let's dive into section 1, the physics of filling. We're going to talk about that invisible enemy that's lurking in your mold before you even take the shot. That enemy, more often than not, is trapped air. The solution is something we all know: air venting. It's really just the process of giving that trapped air an escape route when molten metal comes flying in at incredible speed. If that air has nowhere to go, it gets compressed, trapped, and you get porosity. It's that simple. Now, here's what's really wild, and what this slide shows so well. The amount of air you need to evacuate is massive. We're talking about a volume of trapped air that is roughly 3 times the volume of the final solid part you're making. This just goes to show your venting strategy can't be an afterthought. It has to be a primary design consideration. Think of it this way. It's a super simple analogy. Try to blow up a balloon inside a sealed bottle. You can't do it, right? Because the trapped air has nowhere to go. But the second you poke a little hole in that bottle, a vent, the balloon fills up instantly. Your die works on the exact same principle. So, we've got the physics down. Now, let's connect that fundamental idea to the much larger business demands of today. The definition of die casting excellence is changing fast. It's no longer just about pouring metal the right way. Today, your buyers are judging you on 3 key outcomes. First, do you have a stable, repeatable forming process? Second, are the critical features on your parts consistently machinable without any failures? And third, are your deliveries fully verifiable with complete documentation? It's about the whole package. And here's the crucial point. For sourcing teams, the real cost of a component goes way beyond its unit price. The hidden costs come from that subsurface porosity that causes leaks, the warpage that makes CNC fixtures useless, and the incomplete paperwork that can bring an entire assembly line to a grinding halt. This brings us right to the solution for these modern challenges: an integrated workflow that manages the entire process under one single coordinated chain. A truly integrated chain, well, it starts with design for manufacturability and mold design, flows right through die casting and CNC machining, and only ends after finishing and complete inspection documentation. This whole approach eliminates those handoff points between separate suppliers where errors and miscommunication